Let's look at this example. It says a 25 kilogram crate of chocolate is sitting on a loading dock. Sounds good to me. It needs to be pulled 10 meters to the store. The coefficient of the kinetic friction between the box and the sidewalk is 0.22. And it says, what is the net work done on the crate if the man pulls the box with a force of 60 newtons at an angle of 30 degrees to the horizontal? Okay, so from this diagram we can see that this is the force applied, and this angle here would be our 30 degrees, and this is a force of 60 newtons, and this would be the force of friction. Okay, so let's just draw another free body diagram just to make sure we know what's going on. So remember, free body diagram is just what I tend to call a colored in circle. Remember that you should be drawing this in pencil using a ruler. So we've got the force applied, which is an angle of 30 degrees. You don't have to put the angles in when you draw a free body diagram, but it does help now. There is F normal. There is the force of friction, and here is the force of gravity. Okay, now again, if you were asked to draw the free body diagram, which they usually ask you to do, please remember you need to be using a pencil and you need to be using a ruler to draw these little lines to make them all beautiful. And also, if you can make the length of these lines approximate what you think they might be. So in other words, if you think the F applied is bigger than the force of friction, then that line should be bigger. Now, we know that the net work done, W net, is the sum of all the work. Okay, now we also know that work equals F net delta X cos theta. Okay, so there are two ways you could attack this. You could either find the net force and then use that to work out the net work, or you can go about it by finding out the net work, which is a sum of all the work done by the various forces. Okay, so possibly the easiest way to do this, it depends on which way you think is easier, so you get to choose. I'm going to get the net force. I'm going to get F net. And then I'm going to multiply it by delta X. So by doing that, and then I'm going to say that is the net work done, I'm going to accommodate two forces. I'm going to say, okay, fine, we have got this force here, which is the force applied horizontal, and we've got this force of friction. And both of them are going to be doing work on this big box of chocolate, right? So what we need to do is find the net force of these two and multiply by the change in displacement. That's the one way to do it, and I'm going to do it that way. So the first thing we need to do is realize that the forward force, okay, is going to be this horizontal component, Okay, so then do you agree that if this is the adjacent side and this is the hypotenuse, then do you agree I need to use cos to get the applied force horizontal? So we could say that cos of 30 degrees is going to be the adjacent, which is FA horizontal, over the hypotenuse, which is F applied. Okay, so do you understand that we've got the force forward, but it's at an angle that's pulling the box forward, but we also have the force of friction, which is pulling it backward. So what we're doing right now is we're going, well, the net work is the sum of all the work, but work is the net force times delta X cos theta. Okay, so what I'm doing is I'm working out the net force, but in order to do that, I need to work out the forward force and the backward force, and then I can add them to get the resultant force, and then multiply by delta X cos theta to get the net work. Okay, so that's what we're doing. So the F applied is 60 newtons, right? So then I can go, well, 60 cos the T equals FA horizontal. And now I need to whip out my calculator. There we go. So we've got 60 cos 30 equals 30 root 3, which doesn't help at all. So it's 51.96 newtons. And since that's in the direction of the motion, I'm going to choose that direction as positive. So I'm choosing that direction as positive. Okay, right, excellent. Next, we need to find the force of friction. Okay, so we know the force of friction equals mu k Fn. Awesome. And they've given us mu k, it's 0.22. So that's 0.22 Fn. Now normally, when we have an object, such as this, placed on a surface, and we have horizontal forces, then normally we say that the mg, the force of gravity, is equal to F normal. And we're fine. But in this case, there's a very sneaky vertical component up here, F a vertical, which is actually pulling the crate up a little bit. So if you want to think of it this way, it's actually reducing the force of friction, because this, since the crate is not being lifted off the ground, this plus that has to equal that. Okay, the crate is not moving off the ground, it's only moving to the right. Okay, because it says box pulls an angle of 30 degrees to the horizontal and pulled 10 meters to the store. No, it doesn't say it's lifting it. So therefore we can say, well, we know the net force vertically equals 0, okay? But that equals the sum of all the vertical forces, right? Okay, do we agree? But now, what are they? There's the normal force up, the force of the vertical component of the applied force, and then there's the force of gravity. So again, we have to choose a direction as positive or negative, and for this case, I'm going to choose up as positive. Okay. So therefore, we're going to say that 0 is equal to Fn plus Fa vertical plus minus Fg. Now again, remember, you don't have to write that plus minus, but I tend to write it just so that we don't get confused and forget to multiply by minus sign. So you don't have to do that. You can go straight into minus. The other reason I like to write it like this is you're kind of telling the examiners that you know that the net force is the sum of all the vertical forces, because I'm assuming you're not actually going to be writing that in your exam paper. Right, so what do we have? We have 0 equals Fn plus, now FAV is the opposite side. Opposite side. So again, if we're looking at SOHCAHTOA, SOHCAHTOA, we want the opposite side. We've got the hypotenuse, so we're going to use sine. So we're going to say that, I'm going to write it over here, sine of 30 degrees is equal to FAV, the opposite over the hypotenuse of 60. So that's 60 sine 30 degrees. Okay, so I'm going to fill that in there. That's 60 sine 30 degrees minus Fg is just mass times acceleration due to gravity. So that is the mass of this is 25 times by 9.8. Right, so let's get out our calculator and work out what all that equals. 60 sine 30. And guys, when you're doing this calculation or any calculation on both your maths and your science papers, please make sure that this is in the degrees. On your calculators, it's probably got either a capital R here or a capital D, or it could have a G. Sometimes these calculators change to R, which is radians, but it should have a capital D here. If it's not a capital D and it's R, you're going to get all your sums wrong. So please make sure that that is in degrees. Okay, then we go minus bracket 25 times 9.8 close bracket equals. And that's minus 215. So therefore minus Fn is equal to minus 215 newtons. Obviously then Fn equals 250 newtons. Right, so now we can substitute that back into here. So let's go back to blue. So we can say the force of friction is 0.22 multiplied by 215. And then again, we need our calculator. So we're going to go 0.22 times by 2115 equals 47.3. So that's 47.3 newtons. Excellent. Now I'm just going to erase this because we don't need this right now. Right, so now we've got the forward force of 51.96 newtons, and we've got the reverse of 47.3 due to the force of friction. So F net horizontal is going to be the sum of all the forces, and because we've chosen this as positive, it is going to be 51.96 plus minus 47.3. So again, we need a calculator. So we're going to say it is 51.96 minus 47.3, and that works out to be 4.66. So that's 4.66 newtons, and it's in the positive direction. Finally, your net work done, the work, equals F net delta x cos theta. Okay, so obviously the net force is in the positive direction and it's in the horizontal positive direction. So therefore this would be 4.66 multiplied by the distance of 10 meters. Cos theta is going to be 1 because we're going forward in a horizontal direction. So that works out to be 46.6 joules. Not too difficult, hey, and not nearly worth the calories that 25 kilograms of chocolate is going to have if we ate it. Okay, so that is one way that you can do the question. The other way that you can do this question is you could basically work out the work done by the applied force. Then you do the work done applied by the frictional force, and then you just add them and you will get exactly the same answer. Right, I hope that helped. Have a great day.